Today we are taking a look at tangent lines of circles. So we're going to look at two ways to find missing lengths of these lines. So first, let's review what a tangent line is. So a tangent line is a line that touches a circle one time. So when we're looking at our circle, we have a circle like this, make it pink, and then if we have a tangent line, it touches just once. So our tangent line looks something like this, where that point of tangency is right here, and it just touches the circle and then moves past it. So that is our tangent line. So we're going to look at a tangent line with a radius, and then we're going to look at if we have 2 points of tangency. So first, let's take a look at if we have a tangent line and a radius. So here is our theorem for if we have a radius. In a plane, a line is tangent to a circle if the line is perpendicular to a radius of the circle. So if we remember, perpendicular means that two lines meet at a 90-degree angle. So if our tangent line and the radius make a 90-degree angle, then we can use this theorem. So let's look at an example. Find the values of x. In all the examples, AB is tangent to circle C. So if you see in example 1, we've got AB here, which is 96, and it is tangent to this circle. So that means if I have a radius here, because it goes from center to edge, this is a 90-degree angle. And then you can see that with the radius, with AB, and with this third line here, we have a right triangle. And if we have a right triangle, we can go back to our friend Pythagorean Theorem. So we can use a squared plus b squared equals c squared. We look across from our right angle, we have 100, so that's our c. And then our other two pieces can be a or b. So if I plug these into Pythagorean Theorem, I would end up with 96 squared plus my b is x squared equals c is 100, so I would have 100 squared. And then I can go back and use my calculator, just like we did earlier this semester. Let's see if I can get my calculator to behave. Okay, so we can go math up, enter, and we can use the equation solver. So I can type in 96x squared plus, 96 squared plus x squared. And then in E2, I can put 100 squared. I'll press enter, and then second graph. Ooh, that was not what I wanted. Alpha graph, not second graph, alpha graph. I get 28.00000. If you have point all of these zeros, we can just say 28. So for this one, x equals 28. And that's all. So this is a circle. It does use tangent lines, but it's bringing in what we know about Pythagorean theorem. So it's taking old things and putting it together with new. So we're using both to find that value of x. Let's do one more of these. On letter B, we can see here we have AB, and we know that this is tangent to the radius. So here is our radius because it goes center to edge. So that means this right here is 90 degrees. And then they gave us a third side to make, again, a right triangle. So if I have a right triangle, here I've got two numbers and one missing. So again, we can use Pythagorean theorem. So if I look across from 90 is my C, so that's 80. And then my others will be A and B. So if I have A squared, I can do X squared plus B squared would be 48 squared. And remember, you could do that switched. So you could do 48 squared plus X squared. If you switch the A and B, that is okay. But 80 has to be C. So again, I can go to my calculator, math, enter. And this time I need X squared plus 48 squared. And then in E2, I need 80 squared. So then I'll press enter. I press alpha graph. And this time we get 64. So x equals 64. So for Pythagorean theorem, to use this with circles, this works if we have a radius and a tangent line. But what we're going to look at next is if we have two tangent lines, no radius this time. So this is our points of tangency theorem. It's points with that S because this means that we will have two tangent lines, not just one. So for this theorem, this talks about tangent segments from a common external point are congruent. So when we think about external, this is talking about outside of the circle. And congruent means they are going to be equal. They will be the same size. So let's look at some examples to see what this means. Here we have find the unknown value in all examples. JK is tangent to circle L at point K, and JM is tangent to circle L at M. So all that means is if we look at this, since the center's in the middle and it says L, this is circle L. And then it said that JK was tangent at point K, so that means K touches the circle. And JM is tangent at point M because M touches the circle. So that just means these both tangent. Here they share point J, and they both touch the circle one time. So since these share point J and they both touch, that means that JM is congruent to JK. So that means if JM is 13, JK, we say, is X. Those are the same. So if JM is 13, JK is also 13. So here, X equals 13. That's all this one says, is that those two tangent lines with the shared point are the same. They're equal. So it could be a little bit more complicated, not really, but just by adding more numbers. So here again we have JK, JM, so we know that JK is congruent to JM. So that means on JK, we've got 7x minus 20. That is equal to JM, which is 43. So to solve for x, we can use our calculator again. I can go back to the numeric solver, so I can go math, up, enter, and this time I'll type in 7x minus 20, and then in E2, I'll type in 43. I press enter, then alpha graph, and we get 9. So here, x equals 9. And that's it. All right, we'll do one more, and then you can head to your practice. So again, here we've got JK, and we have JM. Again, they share J. They both touch the circle one time. So I know that JK is congruent to JM. So if JK is 2x plus 2, I know that's equal to JM. And JM is 5x minus 4. So I can go back to my calculator. I can go math, up, enter, and I can type this in. 2x plus 2. And in E2, I've got 5x minus 4. I'll press enter, and then alpha graph. This time, x equals 2. All right, so we're either going to use the two pieces are equal or Pythagorean Theorem to solve for the missing value. All right, if you have any questions, please ask me or Miss B. Otherwise, go ahead and get started on the practice.